Testing, testing. All right, so obviously for some reason it forgot my camera settings. This is just all terrible, and it's almost been an hour. This is just an incredible, total failure. So I really apologize for this incredibly ineffective stream. Camera, where's the camera settings? Here. Balance was somewhere over here. I don't know exactly what. Oh, that just ain't working. What the heck is going on with that? Oh, I can't change scenes while I have this open. Oh, so dumb. Why is this not working? What the heck? Everything is just horribly terrible right now. Don't know what the deal is with it. So I'm just going to have to leave this busted. Yeah, well, Seth, I would have actually just rebooted sooner normally, but since I was on the stream, I was trying to put that off and actually resolve the problem. But and I did test, and it was running fine when OBS wasn't running, at least. So hopefully that will still be true. Let's just go ahead and check that. Anyway, yeah, so like I said, sorry about that. Terrible, terrible waste of your time. So, okay, so this is all working with the numbers back. So now let's push this back to 9, push this back to 4, and see if it's slow again. Which it might still be. Like maybe there's some, I'm hitting some thing that makes things slow. It's still compiling slow. But no, okay, this is reasonable. Okay, so now the idea is, oh, well, I clearly have a bug. Something has a hard-coded dependency somewhere on the mesh size. So now I shouldn't be able to run out of memory. Oh, but I can, oh, that was an out-of-memory bug. Okay, and it happened sooner. That's pretty strange. Yeah, that compiler is still slow. I don't know. Oh yeah, switch scenes. Sorry. Technical incompetence. So yeah, this is all just totally screwed up somehow. It's stacking multiple things on top of each other. So something somewhere is coded wrong. That's very weird. And yeah. Alright, so somebody somewhere cache radius is 1K, which leads to, oh, I changed the mesh chunk size. I didn't want to change the mesh chunk size. I want to change the mesh size, which is this, which is implicit from the cache radius. Okay, so I didn't need to do that at all. Is 6 what it used to be, or 5? It wants to cover 4K by 4K, so it has to be 6. Okay, so that was a dumb thing. I don't know why that broke it exactly, but all right. Oh, because I'm hard-coded to assume 2x2 chunks. Okay, so that's fixed that. And then the question is, will we still out of memory after a while? Because I'm pretty sure now the amount of meshes that are being cached should be small enough. It does not matter. I am getting these spikes. Did I turn off threading? So yeah, you can see the cache size is pretty tiny now. What is that white dot Oh, that's the shot. I must have fired it without paying attention, or... Oh, I always draw it and it's below the ground. It's at 0, 0 out there. Yeah. There was no ground drawing to cover it up. All right, well, it's not crashing, so maybe it is the mesh leak. Although maybe this has just changed some other property of how this renders. Yeah, that jitteriness is crazy. I don't know what... Why is the frame time as high as it is? Am I being V-synced? I guess I'm being V-synced. But it is not running out of memory now. So now I do wonder, maybe it is the... Although I generate a lot less data because I'm doing a smaller radius. So anyway, I'm just going to fly around for a little bit and see if I run out of memory or not. I wish I knew why it was spiking when it loads stuff in, since the threading is supposed to prevent that. You may not be able to see that jitter because the frame rate is so low in the stream, but at 60, it's super obvious when I drop a frame or two or however many it's dropping. You can probably see once in a while the frame time spikes from showing 16 to showing some other number that's got a different first digit. 3, I think. I think I saw 5 just now. And so I don't know why that's happening. Okay, but I don't seem to be crashing. So maybe it really is just the mesh leak and not a memory leak. So let's put it back to 11 and see if I still am getting that spikiness, or if that's something to do with the view distance or something to do with something else. Okay, they're popping in, which they shouldn't, because that implies either I'm caching the wrong distance or they're not building fast enough, which I'm supposed to be doing the right thing. No, I think that's actually the fog is the wrong distance. Okay, wait, let's fix the fog, because that's actually always just been a bug. So, wait, didn't I do this the other day? Didn't I fix the fog? Fog, where do I set fog? No, I didn't. Okay, so here's the thing is I just do some fixed number off the, I must have dreamed that I did this or something. I do some fixed distance off this, but the problem is when the view distance is short, some fraction of this. When the view distance is short, that's not enough. So really it just wants to be mesh chunk size X, probably, something like that. And that might be more than it needs. That's probably a little overkill, but it does mean we'll never see them pop in. They'll always smoothly fade in. Okay, so yeah, it is not jittering the way it was before. So that's some kind of artifact of having the size down so small. The cache so small was causing some problem. All right, so I don't think there is a memory leak now. Given that I just ran for a while without crashing, I think it really is just a leak. Well, it's hard to be sure because, well, no, that cache isn't smaller. But so let's do the manual way of doing a leak check, which is I'm going to look for all my mallocs. Well, I don't want all those mallocs. I'm going to look for all of my mallocs and make sure they're all balanced. So I want to make sure I have a free for every malloc. So does that one show SDB function? Oh, because SDBGL. Why does SDBGL have free? All right, whatever. So there's the corresponding CCC arrow FC, where FC is the fast chunk. So there's a corresponding free, but it's only in reset cache size. Okay. So then what about this one? Okay, so that's the ref count one. So as long as the ref counting is correct, that would be correct. So it's possible the ref counting is wrong. Okay, so then let's go back to this. So load region, free region. It's going to have, yep, that. Compressed chunk. Wait, this is part of cave bars. No, these are not actually even files we use. Okay, mesh builder. There's the files we use. Mesh builder, generate chunk. Mesh builder, free gen chunk. Calls release gen chunk, which does the ref count and does the free of the gen chunk. Okay. Oops, I'm in the wrong data again. There we go, gen chunk. The thread safe queue we don't ever need to free. Mesh worker handler allocates this once outside the loop, so we don't need to free it. Vertex build buffer, face buffer, don't need to. Okay, mesh chunks. So mesh chunks get allocated build mesh. And they get freed only when the cache gets overwritten, which is the source of the potential leak of mesh data that I was talking about. Now, is that the same mesh chunk? Free mesh chunk. Yeah. So every mesh chunk that we get, we put in a queue. Or if it failed to go into the queue, we free it. And outmesh.mc is the same as MC, yeah. So that all seems correct. And we'll have to check those build buffers in a second. Yep, so now we get the build buffers. Again, this is not normally how I would look for this stuff. So that's one place where they get freed. So are those not getting freed? Those may not be getting freed. Normally I would use an automated tool, but not the tool I have isn't thread safe, so that looks suspiciously like those might not be getting freed. So those get created in the mesh builder worker threads, passed back to the renderer. The renderer out here grabs them, grabs the mesh chunk, calls build mesh chunk for reward. No, calls get next build mesh, uploads, etc., and it's supposed to free it here. Now, where did we see that MC was getting freed? We saw the mesh chunk getting freed. Free mesh chunk, maybe? That's not quite correct. Oh, that's, yeah, that's not freeing the MC. That's only freeing that data in it, so that should free the MC. And no, that doesn't free the MC because that's part of the those ones are part of the mesh cache. But these ones that we allocate are not part of the mesh. Oh, this is such a confusing mess. Okay, this is the old path. It calls upload mesh. Let's look at upload mesh and make sure it doesn't free things, because it might. That's inbox will render. No, it doesn't free anything. Set mesh chunk for reward. So that's using. It's been a while since I worked on this stuff too, so I'm now forgetting exactly what some of this does. Get built mesh. Get from queue, non-blocking. Okay, so that just gets an MC out of a queue, and the MCs and the queues are not going to be part of the queue, the cache. So when we build that, upload mesh, that wouldn't be the cache one. So set mesh chunk for reward is the cache one. Okay. And then this needs to free em.mc Oh, it just needs to free. Yeah, needs to free face buffer, free bm.vertex buffer, and I think it needs to free MC. I think that's just. So I think that might have been what was actually the bug. Although obviously I might be freeing a wrong thing somewhere here that we'll catch. Okay, so that one's. Is that somehow the one in the cache at this point? Maybe it is. Well, I can check that because the cache has a name, mesh cache. And the pointers are, where's bm? No, bm.mc. Oh, it's right there. No, bm.mc does not look like it's part of the mesh cache. Come on. R. Yeah. How big is the mesh cache? No, it's not that big. It's 64 by 64. Yeah, so that's not part of the mesh cache. I don't understand why those numbers are so different. I'm surprised it's. I guess that's a pretty big data structure. All right, so where is the MC coming from? It's coming from get. I started to look through this before. It's coming from get next build mesh. Next build, which gets it from the queue of built meshes. So now when we put it in the queue of built meshes, where does it come from? It comes from MC, which is malloc. Yeah, we definitely are pushing a malloc one in. So why can't I free it? Have I already freed it? What's my output function? ODS. Percent. All right, maybe I just should fix my leak checker to be thread safe, and maybe that's the fix here. That's the very first one I try to free. Which would imply it's not some weird bug. It would imply I'm just trying to free something that's not freeable. And yet I just saw upload mesh, writes it to the same one, set mesh chunk for coord. Wait, let me look at this set mesh chunk again then. Maybe it didn't do what I thought it did. What is that? Why can't I find that? Okay. Yeah. Oh, it set mesh chunk for coord. Freeze it. And that's the only one that does. So let's have it not free it because that's surprising. And so it's just freeing it twice in a row. So that would be why that would fail. All right. So now, hopefully, that was it. And now we won't run out of memory, even if I push the view distance all the way back out. All right. So it's not dying. So let's go ahead and push the memory, the view distance back out. View dist 1800. Put it in a release. Run it. We'll see if we still get the. Right, let me check the comments over there. All right. Well, that's crazy moire patterns. So my cache is almost up to 800 megabytes. And so that will still be an issue, is that the mesh cache could overflow the way I've always been talking about in the past. I don't know whether that is living on the GPU or living, because GL is just hiding that for me, so I don't know if the mesh memory is on the GPU or on the CPU or both. I don't know how much memory this GPU has, but I don't know. I think we've been flying for longer than I think I've been flying for longer than I had in the past. So I would guess that this is, in fact, what the bug was, because that would have been leaking a lot of memory, because that was leaking the build buffers, which are sized larger than we expect meshes to be. So I think that might have been it. All right, so that took way longer. It didn't take very long to find. It just took way longer because of all the technical glitches with the computer. But I guess we'll move on to something else then now. Yeah, so this has definitely been running for longer than I was ever able to make it run in the past, so hooray. I'm not sure what I should work on. I guess I could look at my to-do list. See if the stream has any opinions. So yeah, my cache is actually stable. It looks like just under 900 megabytes. It looks like I'm flushing stuff out of the cache. So with the amount of detail things have here, if each chunk had more detail, had more things going vertically or had caves underneath, then the meshes would start getting bigger and we would actually push over that 900 megabyte limit most likely. But because these are not very detailed, like if I took out the trees, they would get even smaller because it would just be a height field. So I do need, as soon as I start putting in more detail, it is going to need to have a hard limit on it. And, you know, if your graphics card had less memory for meshes, you might want to set this limit down. As I said, it needs to match the view distance. So you can't make the cache too small and have a large view distance. So if you start to limit the size of the cache, you're gonna have to limit the view distance. But don't know why the CPU render time is spiking like that. I see it hitting 2 digits some of the time. I need to change this font so the space character is the same width as a digit, so that it doesn't jitter like it currently is when the, well, it's not, is it going to 3 digits? No, it's not. So it's just, why is that jittering? Is the 1 narrower? Maybe the 1 is narrower. Although the Q chunks number, the Q chunks thing is never wobbling, and presumably the Q chunks is hitting 661 or 651 or whatever some of the time, but it doesn't wobble at all. So why does frame time wobble? Maybe it's going down to, no, it's only moving by a pixel. Not sure. Don't really know how that could happen. I guess it could be dropping to only 2 digits some of the time, and the space is different. Not 2 digits. It's going less than 10 milliseconds for some frames, maybe, and then the space doesn't match, and it contracts by a pixel because the space is narrower. Not sure. Anyway, so yeah. All right. So what should I do? let's stop. Let's go ahead and check that in. CD git purge games git status. Fix memory leak of mesh chunk contents. Build buffers. All right. Then we go to do check for memory leaks. I'll need to do that again at some point with the automated tool. We'll work on terrain, fix depth fighting, dynamically set view distance. Did I do that? I might have done that. View dist. No, I haven't. Okay. Yeah, I don't know. None of this sounds super exciting to work on. Let's see. Everyone is just talking about TIS 100. Let me scroll back a little, make sure there wasn't anything for me. I never asked where these colors or textures come from. These are a set of textures Pixar released the week before I started OBBG, which are old textures they used in the 80s and the 90s or something. And they're not very good textures, but they are freely released textures, so they're actually in the GitHub check-in even. They do have a license, but it's a commercial, it's a permissive license even up to commercial stuff. So I wanted to have the default data in here be stuff people could use potentially commercially, because all of my stuff I generally support when I do open source. I generally allow commercial usage. That's like public domain implicitly does that. So Pixar textures. So yeah, you can see the issues with them there. Collision detection might be nice because it is supposed to be a game, not a rendering engine. And so doing physics collision detection would start getting us towards being a game. And the mess of that is that for the physics representation, as well as the mesh representation, and an easy way to store it is just store like 1 byte per voxel. And you might say, I only need the physics representation right around where the player is moving. Like on the server, I need it around all the players and all the monsters or whatever. But, you know, in Minecraft, there's a limit to how far away creatures will follow you. Although I guess they still move around otherwise. So they probably still need collision detection out to your limit of vision. But you could imagine that you might not need it. And the problem is that to compute the physics representation, you still need to generate the terrain data. So if the physics representation were in a square around the player that was, or circle around the player that was much smaller than the view distance, you know, the view distance is 1800, say, right now, and say we kept it only 200 around the player, the problem would still be that I would need to generate the terrain data, the whatever I call that, the gen chunks. I would need to generate those as you moved around to fill in the detail as you moved around. And so I'd be generating all that data once for the terrain meshes way out at 1800, and then I'd be generating a smaller set right around the player as you moved around, and I'd be regenerating data I already generated because I had already, you can see the terrain and you move onto that terrain, and now you're recomputing it just to get the physics rep, which seems kind of dumb. Maybe that is actually the right way to go because you keep a small enough radius around the player. The number of chunks you're generating there are a lot smaller than the ones you're doing for the meshes, so the overhead wouldn't be that bad, but it seems dumb. The problem is that if you want to reuse the data, the mesh chunk data that you're generating, the gen chunk data that you're generating for building the meshes, that's way out at 1800, and that would mean you'd have to keep the full 1800 radius physics representation, which is fine if you can keep that physics representation efficiently. And obviously you can keep the mesh data efficiently, although it's 800 megabytes. So the mesh data is a sparse representation. It's only representing the boundaries of the volume, of the volumetric stuff. So an easy physics representation like 1 byte per voxel doesn't work out to a radius of 1800. You have 4K by 4K. Right, the max views radius is 248, so we have a 496 by 496 by 255 square around the player. Call it 256. That's 2 to the 12. That's 2 to the 12. That's 2 to the 8. So that's 12 plus 12 plus 8 is 2 to the 32, which is 4 gigabytes. So you can't afford to keep the full representation around out to 1800 around the player. I think the server is going to need to keep representations around multiple players, so that's going to be even more inefficient. And you want responsive enemies. That's kind of a big deal. So another possibility would be have 1 bit per voxel, but that would only divide by 8. So that 2 to the 32 I just had would come down to 2 to the 29, which is 500 megabytes, which is still a lot of data. It's smaller than the meshes are right now, though. But the problem is 1 bit per block doesn't actually let you encode varied terrain that's not just solid. You can't encode anything else. So, like, one of the things I want to do is use the sloped block types, and you can do sort of a naive collision detection. You know, like if AIs are trying to spot the player, and you treat a diagonal block as a solid block for their vision, that's not a big deal. But when you're walking on stuff, you'd like to actually know that it's a sloped block so that you walk on it smoothly. So you need more than 1 bit per block. So probably what you need to do is a sparse representation like a run length. And, you know, so even just, as I was saying, just the bits were too much. So I had a possible design here where it was like I could have a min and a max and have 1 bit per block within that range. But as I was saying, 1 bit isn't enough. So you could have a min and a max and have a byte per block. Or you could have a run length where all of the solid blocks are just treated as solid blocks, and then you have something else. So you could have something like 1 byte length solid, 1 byte special type, which is always at the boundary of solids, 1 byte length open air. And then you'd have a special type at the boundary as well. So I guess you could do that like that. And this actually is very similar to the run length encoding used in Ace of Spades, which is the Vox Lab, whatever the Ken Silverman, I've forgotten what that terminology is. He uses a run length encoding like this to encode the color, where the color of the voxel is only visible at the border, and in the interior voxels are always a fixed color. So you could do something like that. But that already is getting kind of big. Like you think about it like a tree, you're going to have 2 runs. You're going to have a run of solid data. I guess you always start solid at the bottom, so you put that last. Well, by default, we're going to have solid at the bottom and air at the top, so let's do that. So you'd need 2 runs for the typical tree case. You have the ground underneath and that, which is 8 bytes per column. So 8 bytes per column times 496 times 496, and we do that math again, and that's 12 plus 12 plus 3, 24 to 27. So that's 512 megabytes. So the thing I said before was 512 megabytes was not. I was doing the math wrong. That was probably a gigabyte. I don't remember what it was. Oh, yeah, it was 4 gigabytes, and then you divide by 8. Yeah, that does come out to this. Whatever. All right. So it shouldn't. It should be 2 to the 29. Oh, 27. 2 to the 27 is 2 to the 7, which is 128. Okay, so that would be 128 megabytes. So that's not terrible. for having that big a radius around the player. But the main issue is just that it's a variable length representation, which I think we have to use no matter what, but it's just that causes allocation, pressure, fragmentation, etc. It's more of a problem on 32-bit than 64-bit, but I'm running 32-bit, so so I don't know what the right thing to do here is. Let's see. If you only RLE from pure solid empty, that's pretty much that thing. Did anyone ever answer it? Yeah, run length encoding. So yeah, run length encoding is just saying that you have a run of the same value, so you can encode it. So you know you have the sequence. So you can encode this sequence of 5s here as, you know, 5 repeated 4 times, and you can encode that somehow. And, you know, so you can encode a byte stream that has this, and then you say 4 5s, and 3 2 1. But the problem is you don't know that that is a run length and these aren't. So then you end up, you know, setting the high bit, say. It's the way it's done in some things. But now none of these, all of these are now limited to 128 values. Or you could, so this would be 132. Or you could do everything as a run, but then each of these is like that. And that data is actually larger than the input data. So run length compression only compresses your data if the data is has enough runs in it, basically. So, well, I'll abstract it so I don't have to get it right. Well, I guess something like that makes sense because I expect that pattern. Because I expect slopes to only be at the top of solid stuff. I don't expect you to build a stack of diagonals. Although I did in my words SB voxel render. I do have in that demo stacks of half height blocks and stacks of diagonals, but they're in this intentional, like, sort of not typical way. On the other hand, you do see people in Minecraft do that. They'll build a wall of half height blocks or something against another wall as a sort of nice effect. But of course, physics-wise, those actually get treated as solid. Yeah, because your person is always more than one thing tall. Yeah, I don't know. So you could try to just do run lengths entirely. You could just do 1 byte length, 1 byte type. And then the tree is going to be solid, slope, air, leaves, air. And so that would be 5 runs, whereas, which would take 10 bytes, whereas this will take 8 bytes. So it's like hard to be sure which thing is the right thing. So yeah, let's just pick one. Let's just pick the easy one, the thing I just showed, which is 1 byte type, 1 byte length. And now the problem is that you have to do this on a grid of columns, and they're each variable length, so you need an index of that, and that starts taking up lots of memory. So the most runs you could have is you could have a 512 length thing because it doesn't compress well. Maybe I should just keep a small thing around the player because I know that the problem is if I keep a small thing around the player, I actually have to go and deal with this mesh builder having another set of logic for dealing with the mesh chunks. Because I now also need to get the mesh chunks. Well, it does reference count them, so maybe it would just work. I need another type of job, I guess. I don't know, it just sounds, I think the two caches might interfere with each other. Like I said, I don't have to get this right. Like, I'm going to abstract everything in a way that means that it won't care how it works under the hood. But I just hate to do it wrong. Like, that's just paralyzed. It's just kind of dumb to have, have that much data. Well, it will let me put, yeah, I don't know. All right, so, physics types. And now that's interesting because there are actually 256 different slope types in the core V height stuff, plus half height blocks. So there's more than 256 possible types, technically. But I think it always ends up that some of those are redundant. So, in fact, I think V heights can represent half height blocks. So I think it's okay to assume there's only 256 unique geometry types. And we'll just start with empty and solid. So this is a collision, let's call it physics chunk. Run, UN8, type UN8 length. Phys chunk column. We could have a length for the total thing, but we can also just wait until the total length reaches 255. So we don't actually have to do that. Then we have struct phys chunk, and let's size these the same as gen chunks for simplicity. So we need gen chunk size x, size y, size x. Where do we want these to live? Let's, for now, to get it working, actually put the phys chunk inside the mesh chunk. It's not where I want it to be in the long run, but it's going to get generated at the same time. So for simplicity, we'll do that. So when we create a mesh chunk, there, right there, that'll copy it. So, boom, here, we've gotten the gen chunk. Do we use this? This is the old path, right? This is the non-threaded path. Yeah, that's the non-threaded path. So let's find the threaded path. I'm done with all this. I'm done with the thread logic, so I can bury that comment. Let's go ahead, and this was something somebody was coming. That's probably not realistic ever to use that many. Like, if it's fast enough with this, why would you ever need that? And that will now reduce the amount of memory we're using, which will allow me to bump these up actually effectively so that we can deal with larger. So that uses 32 times 16, which is 512 megabytes. So it's actually that. Oh, but right, those have to be. Let's actually, so this has to just get dealt with. There's a correct way to deal with that, and let's deal with that later. The correct way. So here's where we build the mesh. and there's where we release the gen chunk. So generate mesh for chunk set is where we want to do it, because that's also in here. Yeah, so generate mesh for chunk set has all the mesh data, and we can go ahead and create the physics rep. So well, let's just have a terrible speed, hit, and go ahead and just do it the brute force way. So copy chunk set to segment. So copy chunk set to fizz. Let's just call it build fizz chunk. Let's see. From chunk set. So would build fizz chunk. See, this is going to be a lot of little allocations. I don't want to do a lot of little allocations because the allocator has to be thread safe, and that's putting pressure on a semaphore on the allocator if I do lots of little allocations. That's one of the problems with these variable size things, which is why I avoid variable size things. So I guess we'll do this with a little arena allocator. So I don't think I have one in STB that I want to use, so I'll need to write a little thing. So def struct arena. I guess we can use an STB array for these. Also, we don't need to have any linked lists. So arena chunk. Size T, capacity, size T in use. So void star arena alloc arena chunks arena chunk chunks size. End. So if there are no chunks, or if I had something for this last chunks, or PC rather, dot in use. Use plus size is greater than per capacity. We need to allocate a new one. ST arena chunk size. So then arena chunk size is STB small. We need to increase it up to the actual size. Then we need to say cur equals malloc arena chunk size plus size of arena chunk minus 1. And capacity equals arena chunk size and in use equals 0. Now we push that on the end, and that's actually the only place where we need to write that, so let's only do it there. And we need to get that back again. So we're writing to the correct one. Okay, so at this point, assert cur use plus size is equal to cur capacity. And I'll pull this out and put it into STB at some point. Cur data plus cur in use. Cur in use plus equal size. And return P. Do I need to do anything else there? Void arena free. All arena chunks. Okay. So, and again, I have that problem that when I'm streaming, I don't write comments. I just say the stuff out loud. So that's why this code is terrible. I really, maybe off stream, I'll go through and try to make a pass and add comments to all the code in the whole thing. Or we could make that a project. Maybe people watching the stream could add comments to the code, and people watching it archived, not watching it live. They could check it out and watch the stream and add the comments and then submit pull requests. Build phys junk. Okay, so what we have to do is we have to go through the chunks. So we gotta go through the columns rather. So arena chunks equals, oh, hey, I have a different meaning of chunks. That's terrible. Okay. Arena chunks, I'll do it that way. Equals, no. For y equals 0, y less than, oh, I'm doing this on, I wanted to do this on gen chunk size, but I'm storing it in the mesh cache, which is mesh cache sized. So I've got to change that. And we'll change that probably. I should build and see how many build errors I have. What is it called? Oh, I mean, oh, because this needs to be down after this stuff. So let's put all the calculations up to the top. Cur is a chunks. Yeah, we have to push star cur, which is why we need to reload it. Free. Actual parameter is not a pointer. Yeah, it's oh, I'm doing all this wrong. Okay, right. So yeah, these need to be, this needs to be an array because I'm storing the data at the end instead of storing a pointer inside it. This needs to be an array of pointers to arena chunks. And then I'm going to have to add more levels of indirection to a couple of these. So then this one needs to be a double star. This one needs to be a triple star because it needs to actually be writable. Then that does that. And then that's that. That's that. Okay. So this goes to mesh chunk size. Okay. I don't know what Abner was laughing at, but because it was way back in the scroll back and the lag. So we have to get it from the right chunk. I must have code to deal with this already somewhere. Oh, it's all this mess. Yeah, I guess it's a simpler version because I don't need to do. I guess I got to come with all this. I only need to go from 1 to 2. I don't need to go off the edges. That would be probably clearer to go less than equal to 2. Why is it +1? What's the +1 for? Oh, that's, yeah. Not true in this case. That stuff will never happen. And then this needs to go over gen chunk size. Well, I guess that's just x0 to x1. Yeah, so I don't need these. Yeah, okay. So build fizz column. Let's go ahead and make an arena where we reserve, we unalloc, void arena release. So release unused memory from end class allocation. Then we can just allocate more than we actually need. Use that to validate it. So, oh, we can't actually use it to validate, so we just have to use it correctly. So, so chunks of, so SB array last chunks arrow in use equal size. Okay. So build fizz column of, let's see, arrow. What was it called? Physics chunk? Is that that? No, that must be something else. Fizz chunk. Oh, it is called PC. Oh, we don't know why I didn't. Oh, arrow, PC, arrow, column, of y off plus y, x off plus x. Equals build physics column of chunks, chunk of j of I, x and y. All right. Build fizz column. That just takes a single chunk of what type? I don't even know. Chunk set. Is that chunk set even in this file? gen chunks, right. Gen chunk, GC, X, Y. All right, so the largest a column might be, so this is called a fizz chunk run. Run is arena alloc, so we need that to pass that down. Let's just go ahead and pass the mesh chunk. And let's have MC arrow. What was it called? Alex. Is that double starred now? Yeah. No. Let's not use AC here. So we pass MC down. So we arena alloc MC Alex. The amount of error we need, which is Z max Z times 2, and the arena chunk size. So this is going to get allocated for every chunk. And we have what, 4K at most. We have 2 to the 12 mesh chunks. So if I allocate, say, a minimum of 64 kilobytes for each, that would be 2 to the 12 plus 16. No, 64K. Yeah, 16. Which would be 2 to the 28, which is huge. So I probably don't want to have the minimum be 64K. Then how big is the minimum? The minimum is 4 runs. 2 runs times 2 bytes, so that's 4 bytes times, how big is the mesh chunk? 64 by 64, so that's 2 to the 2 plus 6 plus 6, it's 12, 14. So the minimum size is 16K. It's definitely going to be at least 16K. So we actually want to use smaller than 16K. So that's still going to be a bunch of allocs. So like if one is 16K, it'll take at least 2 allocations. But that's not too bad. And then all these allocations are fixed size, so we can eventually push them off into their own pool and not even go through the normal allocator. Okay, so now we need to compress that. So GC arrow. What's it called? Partial, I guess. Block. Okay, so int z for z equals 0, z less than 255 plus z. I wrote this code somewhere else, different case. I don't remember what it was, but it's 1. If GC arrow partial arrow block of z shift right 4. No, what is it? Partial of z shift right 4 dot block of y of x of z and 15. Let's try that. And then now currently that has, so that's does not equal bt empty, because currently that encodes the texture, not just the geometry. So eventually that would become a table lookup. And then we need to compare that to the previous one. So we just gonna have to compute that again. Read type. Totally dumb. We'll change how this works for efficiency reasons later. -1. C -1. Int run length equals 1. If type does not equal type, type does not equal type. It's not a very good test. Type. So 0. Then we need to output it. So we say PR of data off dot type equals brief type. PR of data off dot type equals run length. We start a new run that's like 1, else plus run length. And then we need to write the last run. We need to increment data off. Then we need to say PR of data off type equals brief type. Oh, we don't have brief type. So dumb. BT empty. PR data off dot run length dot length equals run length. Got that wrong up here. All right. PR plus data off. Now, how much did I use? I used data off times 2. So I say arena release. Let's see, Alex of max z times 2 minus data off times 2. And then this chunk run. I return that. Okay, and then when I free a chunk, free mesh chunk. So here I copy it, so I don't need to free anything about it. But that one I free. Okay, so free mesh chunk has to do it. And then what was the whole fix in the other one? That was of the build buffer, which didn't stick around. So the free mesh chunk will do the right thing. Okay, so free mesh chunk. Free mesh chunk has to actually free. Yeah, okay, right. I should probably change that so the mesh chunk itself is malloc, so that this would be less confusing. I equal std r len of mc alex free mc alex of I. There we go. Redefinition. So this must not have enough curly braces. No. Oh, it's right above it. Sorry. Duh. X off X is definitely not correct. That one has the wrong curly brace matching. All right. Let's just run it. See if it crashes somewhere. Hey, look, it crashed somewhere. Yes, I can't do that if it's not 0 length. So is equals null. All right. So this is MCPC. Did I not? What? Oh, I'm in a release. Let's see, PC is on it. Okay, so I made fizz chunk. So let's inline fizz chunk. How big is that? 64 times 64 times 4. So to the 12 to the 14. Wait, what? 64 times 64 is 4K times 4. 16K. What did I get? 2 to 6 times 2 to 6 is 12. Oh, 12. It's not a megabyte. That's a K. Yeah. Did I do that earlier? Did I call 2 to the 10? Did I, in one of those math things I was doing, did I call 2 to the 10 a megabyte? That would mean I totally overestimated the size of something. Yep, that is like that now. All right. All right. So hopefully that's all working. Let's see if we run out of memory. Oh, yeah, I probably did. Unfortunately, I was holding down spacebar because spacebar is my fly key. I should probably rebind that so that that doesn't keep happening. Or it's my move upwards key. There we go. Hey, look, out of memory. Okay, so it could be a memory leak, or it could just be that I'm using a lot more memory now because I'm storing all that data. Because I haven't moved far enough that it would even free anything at this point. So let's increase the size of the mesh, but not actually do any column allocations. See what that does. But that should be a small increase. That should be like 16K per mesh. Yeah, for more than 3 slots per program in TIS, you can open the save directory and they're just text files and you can copy them around to make room. But it's super annoying. Because I have like one that's optimized for cycle time, one that's optimized for instruction count, and I'd like to keep both of those around. And then I have a current one that I'm working on, and then maybe I want to fork that one that I'm working on. In the one particular case, I actually have 3 reference implementations I want to save. The third one is my weird sequence reverser. I have a weird challenge for that, so I have a saved one from that. And so I have 3 saved ones for sequence reverser and can't overwrite any of them when I want to do something. All right, so it's definitely these things. And like I said, I don't think I'm going far enough for that to have been a leak. So am I doing something weird here? Is it possible that this is not... Am I never saying capacity? No, I said capacity. Is it possible that this logic is wrong and I'm always allocating a new one every time? Something like that. Else equals cur. Let's break on that, make sure we don't always hit the other case. Ho ho. Look what I just noticed. See, that's just like a random guess. Like, how did I debug that, right? I had no clue there was an actual bug here. I'm just like, it's possible there's a bug here, so let's check. So why did I nail down to that? Let's think about that. This is not something I would normally do, but since I'm on the chat, that only uses 411 cycles. Isn't mine faster than that? I don't remember what I tweeted. Or was that? Oh, that's right. It was the 450s to 430s was where mine were. Yeah. Yeah, I hope we stick with the dynamic ones are faster than the static ones because that makes that challenge more interesting. Well, it's not a matter of, well, it depends what you mean by changing the inputs. Like, I don't consider hard coding to the length of the inputs if the lengths are always fixed, or, you know, if the numbers are always 1 digit, I don't think it's bad to hard code to the assumption the number is always 1 digit. And so if like the lengths, like in sequence indexer, the lengths are always length 10. So I'm not sure it's bad to hard code to that. So hard coding to the stacks are only 15. So you could do a hard coded delay that makes it only work 15 or less is not bad. And then tuning that so it only works on length 8 or shorter or whatever it is in sequence reverser, I don't know, isn't like, I don't want to call that cheating. Yeah. Anyway, so how is it that I've guessed correctly where this bug was? So 2 issues. One is I was allocating too much data, which fingers the only things in here that I added to allocate are this And this implicitly allocates if it needs to grow the array, which I never free. So that is a bug. But the amount of memory there is tiny. So my suspicion was that this stuff was running too often. And so like so obviously it means this if that were the case, then it would be that this if was running too often. And the most likely way to run too often to get this have a bug here is that it just always goes that way. So that was where I went with it. And another version of that I talked about before is that my rule of thumb is that conditional branches are the source of most bugs. And it's probably not universally true, but it is often true. So, you know, fence post error is a common error, and that's a kind of conditional bug. Because if your code follows the right flow, it's pretty rare to have a bug. You can definitely like, oh, I forgot to increment I, you know, or whatever. It's definitely not a conditional bug. But when things sporadically go wrong, conditionals are going to be at the heart of that. So what is wrong with this logic? Well, it's really hard for me to tell because it's split. I can't easily do this. So so one possibility is that this is always 0, but I'm running it back here, so that should be okay. And the other possibility is that this test is always true, but my size is small, my in use is small. So yeah, I need a breakpoint here, and the problem is that I need this as 2 separate tests so I can breakpoint it. So I'm going to do this terrible way. Like that. So I can breakpoint in the right place. Or it might never hit this one, but I would think. Capacity 510, in use 8, size 510. Wait, why is capacity? Oh, because I take a min instead of the max. Yeah. Hey, look, that's a conditional operation implicitly. Oh, I don't need to exit. Sorry, I always have to exit at work because I run in 64-bit at work, and VC6 has this problem that makes me exit. All right, so that probably fixes that. So we have to run for a while and see if we out of memory or not. Can I turn up the volume? So yeah, the issue there is just that if I get too close to the mic, it'll get a lot louder. But yes, I can. So everybody turn down your mic a little bit, or your speakers, or whatever. Okay. Now I can go a little higher. So the only problem is if I actually get close to the mic. And I used to get really close to the mic, but I've moved the mic. I'll just move it a little closer. I've moved the mic to keep it out of the frame. That's the problem. So there we go. All right. And also if I look away from the mic and mic discipline. All right. So did this just crash? No. Okay. So I think that was that memory leak, which wasn't even a memory leak. It was just a rambunctious over allocation. And I've already even forgotten what it was. I fixed it, and I've blanked out what I fixed. So now I'm, in theory, storing collision data that are, you know, physics data that I can use for collision detection. So the next step then is to write the collision detection. But I think it's been a 2-hour stream, and I'm going to stop here with that stuff being generated. So out of curiosity, do we ever even hit this line? Probably not. Oh no, right, we do. We should always hit it twice per block. That's right. Yeah, okay. Yeah, AC is different every time. Yeah, okay. So, there we go. Maybe look at this and see how much we're subtracting back out every time. It should be a lot. we're allocating 512, but we've only used 10 or 15 bytes of it. So the normal way you would write this is you would build the vertical column data into a temp buffer and then allocate the space for it. And I wanted to just skip going through that temp buffer, the memory traffic for that. So I allocate a large enough block for it and then contract that block. And I can only do that because I'm using this arena thing. It doesn't mean I waste 500 bytes at the end of every arena, but it's pretty reasonable. All right, so yeah, I'll take a look at questions in chat after I stop the stream. So, and I'll check this in right now. All right, so thanks for watching, guys.